Assalamualaikum warahmatullahi wabarakatuh. First of all, I will introduce myself. My name is Aiman Bin Noor Zelan, which my student ID is 2023 128791. I am a postgrad student of Master of Science in Electrical Engineering, which is my course code is CEEE750. Today, I will presenting my progress report for my semester 1. So for my research supervisor, I have two supervisors, which is my main supervisor, Associate Prof. Dr. Muhammad Nabil bin Hidayat, and my co-supervisor, Technologist Dr. Nick Hakimi bin Nek Ali. So the title of my research is Design of the Bidirectional DC-DC Converter with Governing Isolation between the DC Charger and Energy Storage System ESS. So a brief introduction of my research. So the study focused on the designing a bidirectional DC-DC converter with governing isolation for seamless integration between a DC charger and an energy storage system ESS. This integration is vital for addressing fluctuating energy demands and utilizing renewable energy sources efficiently. The governing isolation converter ensure the electrical safety and eliminated ground loop issue. This is our crucial part. And the aim and the research aim is to optimize converter topology, which plan to use a variation of the push-pull converter, which benefit of the bidirectional isolation, high efficiency, and also it is also one of the wide range of application. So for the bidirectional isolation, like the other transformer-based isolation method, the push-pull converter offers the bidirectional energy flow between the input and output sides. This characteristic is useful in applications that require both charging and discharging capabilities. And for the high efficiency, the push-pull converter is known for its high efficiency due to the effective use of the transformer and the push-pull switching operation. So lastly, the wide range of application. The push-pull converter is a versatile and fine application in various power electric systems, including the DC-DC converter, power inverter, and switch mode power supplies. Next, the status of my major research milestone. As you can see in my slide, for my research paper, we have three problem statements that will generate three objectives, and also lastly for the outcome, we have also have a three outcome. So for the problem statement, for my research program, I mean for my title, so the problem is one of them is a lack of information uh, in regards of for the parameter bidirectional that integrate with the DC charger and energy storage system. Next, as you can see for my design of the DC converter, it consists of the transformer. So the problem is maybe of the will be causes the expensive cost of the designing the isolated converter. So due to the complicated circuit design, it also relate with the expensive cost because of the presence of the transformer. So I need to consider the what type of transformer and safety protection to safeguard the transformer. So for the last, the third problem statement is related with the hard switching. If you be concerned that is related if I designing plan to design the DC-DC converter, a lot of converter and maybe all the converter have the what we call that the switching part, and also the switching noise will occur due to the hard switching. So it come up with the three objective lah, which is the to simulate and design the isolated bidirectional converter, complete with the test rig, which include the DC charger and energy storage system. So next objective, to perform a converter topology system with the governor isolation, which is I plan to use the various of push and pull converter. So the third objective to design it related with the switch and want to design the implement the soft switching technology by using the snapper circuit. So we have five methodology to make the three outcome, which is one of them is to identify the whole process of the converter full system. So next to identify the converter topology, After that, we simulate and converter the converter in the full system. Fourthly, we can observe and analyze data comparison simulation and actual hardware. So lastly, we construct the hardware for the convertible system in the small scales. So the outcome, we able to obtain the full design accelerated bidirectional converter and to meet the nominal power converter to be tested in the small scale hardware system. So next, second outcome is we were able to develop converter system preventing the DC and unwanted AC current between input and output, while still allowing signal and power transfer between those two parts with high immunity against distortion in input means. The transient voltage surge will be reduced and ensuring reliable and safe operation. So last outcome, we're able to mitigate voltage spike and reduce switching losses in bidirectional DC converter with galvanic isolation. So ensuring to improve efficiency and reliability during the integration between the DC charger and the Z storage system ESS. So this is my flow chart for my master course program. So it consists uh, for consists main part is the software development and also the hardware development. So for the software development, I focus on the semester one. So after we achieve and complete the simulation for the semester one, we will pursue for to the next program and next process is which is we when go to for hardware development. So this is for my semester one progress. I already test simulation overall system. As far you're concerned that what I mean the overall system is consist of the solar system, the energy storage system ESS, DC charger, electrical vehicle, which they act as a load, and also the main crucial part for my research program is to develop and design the bidirectional DC converter, which is focusing on the galvanic isolation. So as you can see from the block diagram, this is and also the simulation for the MATLAB. I already finished up the simulation, and right now currently we process for the to convert from the MATLAB into the hardware in loop, which is using the Typhoon software. So currently we still develop the simulation by using the Typhoon hardware in loop. And this is my Gantt chart. So as you can see for my Gantt chart, this is my plan for overall my overall plan on master program. So as you can see, it consists 4 semesters, which is semester 1, 2, 3, and 4. Is divided by the exploration, which is the software development for the semester 1. So in the semester 2, the plan for the semester 2 focusing on the execution, we say the hardware development. So for the semester 3, we can see that after we achieve the hardware test rig in the full system, and we can that we can make we can collect the data processing analysis. So that time we can for the semester 3 we can demonstrate and evaluate phase of the system full system. So for the semester 4 especially is related with the thesis submitted lah. So the consists of the thesis report and viva, thesis correction, thesis formatted, and lastly approval for the senate. Next, the status of my publication. As far as far you have been concerned that I already attend for the 6th International Conference on the Clean Energy and Technology 2023 on 7 and 8 June 2023. That been held at Penang. So I already performed. Published the simulation-based investigation into the charging performance of lithium-ion and lead-acid battery in the electrical vehicle. So for the status, the submission already submit and waiting for the endorsement. Okay, next the status of the thesis writing. As you can see, for the semester 1, I waiting for I prepare the RP proposal because of the process progress on the different DRP writing to be submitted and endorsed by SBI in abstract by 18 August 2020. So this is the percentage that I have been done in progress, which consists a lot of information is focusing on for my DRP defense research proposal. So that's the status of my proposal. Okay, next, but not least, the lastly for the planning for the next semester, as I've been present before this at the Gantt chart, that for the semester 2, the planning for the next semester, I will focusing after I done for my simulation in the MATLAB and also the hardware loop, we focus on the execution on the hardware development. So the hardware development is consists of the material, equipment, and tool selection first, and also the development hardware prototype solution. So after I planned the next semester after I had done the hardware development, is the time is on the track and also is become earlier from what I planned. So at that time, maybe the next semester I will collect all the data processing and analysis. So from there we can know and compare for the DC converter, which is what we can achieve all the objective and also the outcome for the my research purpose. Okay, thank you very much for your time. And if any information, you can email me and also contact me as been stated at the information below. So thank you. Assalamualaikum warahmatullahi wabarakatuh.